and I'd like to reintroduce to you Karl Mäsak, also known by his nickname Mäsak. He is a long-term Perl6 developer, a very active member of our community, also a consultant, a trainer, a father, and all in all, a full-stack human. So, Mäsak, please take it away.
Thank you very much for that comprehensive introduction. Apparently, I'm starting by throwing money on the ground. Good start of a talk. And thank you for showing up for this second day where I happen to also have a talk. Yesterday, I tormented you with extreme philosophy. Today, I'm going to torment you with extreme practice. And I have fewer slides, but I'm more nervous about running out of time. That's because practice is hard. Theory is quite easy in comparison, but practice is difficult. First, I'd like to issue a small correction, which will make absolutely no sense to a person who was not on my previous talk yesterday. You have been warned. I told an anecdote about daytimes and Argentina, and I had forgotten completely who made this anecdote in a bar in an evening at a Perl event some years ago. It turns out it was Dom, and I was told this by Dom, and it was actually Brazil, so now you know. So this is Argentina, that was the wrong country, this is Brazil. They are the ones with the crazy daytime handling. So now you know that. On to something completely different, namely macros in Perl 6. Now, Perl 6 has some rudimentary form of macros already. I took on a grant a couple of years ago. It's actually too many years ago. And I implemented macros to a certain point, and they are in the language, in the implementation. Right now under a pragma, I think you have to opt into them because they are a little bit experimental still. But back in October 2014, I felt we had reached a point where we had actually followed the spec in implementing these macros, and it didn't quite work out, it didn't quite fit. And when I went back and looked at it, it turns out it was because we've been wanting macros for a very long time. Actually, ever since Perl 6 looked a whole lot more like Perl 5, and ever since before we landed grammars the way we have now, and we landed slangs the way we have now, and so on. So I felt like within the scope of the grant, I needed to take a fresh look at things and see what we actually wanted from macros, now that we know all that we know several years later. So the spec is too old, it needs to be modernized and rethought a little bit. And I didn't know it at the time when I wrote this blog post, but soon thereafter, a couple of months thereafter, I was basically implementing a language playground in which we could quickly iterate on macros. And that turned out to be this James Bond-inspired language 007. And that turned out to be the sort of the main part of the yak shaving here that I'm going to talk about today. So I'm here to introduce to you a new language. I'm very proud to do so. I'm at about the same time, in the same December, I became not just a parent, but also an owner and a creator of a language. And this is not a language tutorial because we don't have time for that. I could literally spend the rest of the talk going through details of the language and explaining it all to you. And that would be a very fun talk to give. But that's not this talk, so I'm going to take a couple of shortcuts. I'm going to summarize things to you. A very easy way to describe 007 to a newcomer is to say that it's a sort of unholy mix of primarily Perl 6 and Python, but also a little bit of JavaScript thrown in, primarily with its object notation. Now, the object notation is a bit new, so it doesn't show up in this table here, but basically in the choice between braces and indentation, we chose braces in 007. Yay! And Python doesn't have user-defined operators, at least not the way we do in Perl 6. In Perl 6, we simply define a sub with a funny name, and we get an operator right in the language. And we can do that in 007 as well. It's very easy to use. It was quite tricky to implement. We have variable declarations, which is a good thing, especially when you're doing macros and so on. You want these explicit declarations and not the accidental way to declare variables like you have in Python. And yes, we do have macros, which is sort of the main point of the language. And what we'll be building up to here, we'll first introduce the language and see that it's a fairly normal, standard, almost boring language, which takes the easy way out in a number of cases, which makes it less like Perl and more like Python, actually. So here's the ways in which 007 is like Python. We don't do implicit typecasts, which means that you can't just add together a number and a string, and just by using the right operator, the language will cast the right values for you. So you will see a bunch more casts here. We need to cast to string and int and so on in various cases where we wouldn't in Perl. We also don't have sigils. That's not a big thing. It's just something that distinguishes 007 from Perl. We don't have multi-methods, basically because that's not on the hot path to exploring macros and so on. It would be cooler to have multi-methods, but it would just be more code in the implementation, and we don't want that. Also, one thing that you might be annoyed by in these examples is we need to return values from a function. Once we declare a function, there's no implicit value just falls out of the bottom of the function. We need to actually explicitly return it. This is also just a choice from simplicity, because that means we have to do less implementation code and think less about those things. So I'm going to switch over to a live demo, and because there's a social event tonight, the perfect thing to implement, I thought, would be 99 bottles of beer on the wall. And so this will be your first encounter with with 007. Yes, we have a question already. The language supports starting from any number, not just 99. And English language too, yes. They're very compatible in this regard. Just plain maximizing the screen would be too easy, so I'm going to do this instead. This is a REPL, one that I use privately. I really should commit it to the repository. I'll show you the limitations of this, so you'll get disappointed up front. Namely, if we do my beers equals 99 here, that works. Then we can do say beers like that, but we cannot do say beers here because this is a fake. The REPL is restarting all the time. It's not a fault in the language, it's a fault in the REPL. Oh, I might as well show you the source code so you see what's going on. It's a very small thing, and you see it does RL wrap up there, and that's it. Okay, so let's implement 99 bottles of beer. First, we're going to need a utility subroutine. We call it plural, and it takes n things of some kind. And what we'll do here is check if n equals 1, then we have one case. That's when we return, and here's where we stringify, and we have to do that. So in 007, we torment the user on behalf of the implementer. So, and here's just n thing, right? That looks right. We do have else statements. Fairly late edition. You can get quite far in using a language without else statements, but when it turns out that you benefit from it when you actually write real-world examples, like 99 bottles of beer. So here we return instead stir n, and it's fairly similar here. If we had a trinary operator, we could do things more nicely, but we don't. You could define it, I guess, with some difficulty by hand. Okay, let's just test that this one works. Plural, and someone shouted no, so I'm going to go 999 beers instead, and I should leave out the s, right? Unable to parse program because I missed a parenthesis. There we go. Okay, this seems to work. Good. Next up is implementing a subroutine called verse, which will have these 4 lines that you all know and love. Like a master chef, I've prepared it here beforehand, so I don't have to write it out. But we can talk a little bit about it after I've pasted it in, and we try it out. So what we're doing here is we're using this plural, so it says 99 bottles of beer on the wall, and next line also 99 bottles of beer. Then a constant line here, take one down, pass it around, and this plural here is already using the fact that we've removed one bottle, so it's calling plural n-1 of beer on the wall. And then we're trying it out here, I missed the parenthesis, and you see the result is here. Already from this you see that 007 is a fairly rounded off language from this. We have all these operators, we have the ability to define subroutines. It's not shown here, but I could easily have put the plural subroutine inside of the verse subroutine. That would just work out fine, and plural would be local to verse, and all this works out because it's already implemented in the language. So it's basically a sort of very pared down Perl 6, if you will. Okay, the last bit that we need is to actually call this one enough times here in a while loop. So I'm going to declare my beers variable. And because I have this RL wrap, I can actually, let's run it once and then do it from 999 as well. So you see that this is all very much not fake. Beers -1, and I was missing a closing here. So yes, we have while loops here as well. And 007 is a little bit nice here. It has this notion of truthy and falsy. So you could write here while beers is non-equal to 0, but we can get away here with writing while beers because 0 has the false property when we're doing it in while and if and so on. We don't go so far as having until and unless in the language, but that seems like a rife opportunity for statement macros once we get that far. So you can actually add statement forms to the language. Okay, let's try this. Variable verse is not declared. Of course it's not, because here instead of calling verse, we should be pasting here, right, and the closing brace. This is not a good way to evolve code. You should do it in an editor, of course. But just for the sake of the demo, we're in an interactive environment. And for the sake of showing that it was not fake, yeah, here we are. We're actually implementing, we're running off of the parsed AST here, so it's not very efficient. We could run this a whole lot more efficiently by compiling it, but that's also not part of the exercise here of exploring language things. So here, for the first time in a long time, I'm actually suffering from the slowness of 007. But you see it working, and when I switch away from this one, it will basically complete. By the way, we have integers and not floating point numbers, because floating point numbers are also not very interesting when you're, and there we're done, when you're supposed to implement macros. So we have 4 primitive types in the language, I think. We have strings, we have integers, and we have a non-value, which is sort of this generic undefined thing. Oh, that's 3 primitive types, actually. And then we also have arrays and objects as slightly more composed things. Okay, let's go back to the slides. In some sense, everything I've done before as part of the Perl 6 project has led up to this point. I feel like I'm the prime candidate to take on this kind of project and explore macros in Perl 6 in one of these toy languages. The first big project I did was, it's called the Glacial Grammar Engine. It's a re-implementation of what was then our ruling grammar engine in Parrot. It was called the PGE. And I wanted to understand macros better, and I wanted to understand grammar engines better. So I basically went and implemented one. My long-term goal was that I would be one of the people getting the sort of self-hosting nature of grammars in Perl 6 quite early. I was obsessed with the idea of parsing Perl 6 with Perl 6 and so on. We're almost there now, even without GG, but we still have a few sort of loose ends to tie together. But GGE was an early attempt at that, and you see my fascination or my acceptance of slowness was with me even then. So I'm not doing this in order to be terribly efficient. I'm doing it in order to try out new ground and so on. Same thing with YAPC, actually. YAPC is the compiler with a provocative name. It chose the same name as a Perl conference, but it stands for yet another Perl 6 implementation. And it's basically Perl 6 in Perl 6, also very slow. In that case, we did not actually run right off the AST. Instead, we had a serialization format, also confusingly named SICK. So YAPC emitted SICK and then ran off of it. YAPC actually didn't get very far as a project. It was mostly known for its release announcements. But it was a fun experiment, and it gave me a solid footing implementing things like blocks and scoping and subroutines, and basically realizing that, hey, there's not much magic to this. It takes a number of rudimentary skills to become a language implementer and a compiler writer, but it's not a whole lot. It's actually less than what you would get, for example, if you would take a CS degree and get all these, automata lessons and so on. Part of the reason why this is extremely easy in Perl 6 is that Perl 6 gives you a kind of toolkit to write compilers. I'll show you some code up soon where this becomes very evident. So you can think high and nice thoughts, and they come out as very clean and brief and relatable in Perl 6. The final, and this is the smallest project as well, that I did just before I embarked on the 007 adventure, was a metacircular Lisp in Perl 6. And everyone should implement a metacircular Lisp at some point, just to feel the sort of, whoa, the language that's implementing is actually the language that's being implemented, whoa. And you have this eval, apply loop and so on. Actually, for me, I'd like to hear this from someone else, but for me it was a fairly short love affair. I got it working, and then I went, okay, self-hosting metacircular interpreter, now what? And it was this disappointment that basically led me onto 007, because I felt that whatever I had with Ipso, it was something very Lisp-like, but it wasn't something that I could evolve into this language environment where I could try out Perl 6 ideas. And that could be one of the topics of today, sort of at least subtly hidden, that Perl 6 is not Lisp. And the ways it is not Lisp are very interesting for someone like me who is supposed to implement Lisp-like macros in Perl 6. And yeah, we can come back to that and talk about that later. So all I've shown you so far about the languages is fairly straightforward, and it wouldn't be an interesting language if we just stopped there and said, okay, and that's 007. But you've all seen this. This is a DOM structure, not that DOM, but the DOM of HTML. The HTML in question here happens to be the tutorial of 007. So yes, it has a tutorial. You can reach it via the GitHub project. And this is the structure. It's a very object-oriented view of a document, basically. Every line here, block quote and P and table and so on, we suddenly see it as an object with nested objects inside of it and so on. And 007 has this. For every program that you have, and here is one of the simplest programs you can think about, you have a DOM structure coming along with that program. And this DOM structure is available inside of the program as well and can be manipulated. And this is the starting point of macros. So here you see that one. You see that it's a bit bigger than the program itself, but every piece here is nicely explainable. Sort of at the outermost level, we have a comp unit. It directly contains a block. You don't see the block here because every program has some kind of invisible braces around it. That's just for nice structure, which means that it also never uses its parameter list. It just comes along for the ride here. Then we have a statement list of exactly one statement. The statement in this case is one of these expression statements, which means that this one contains an arbitrary expression. What's the expression? Well, it's a postfix operator call. That's the parentheses there. By the way, you always need the parentheses in 007. I've several times been tempted to do a form where you didn't need them, but that's also excessive, just trying to please the user, and I'm not out for that. So the postfix call here, it talks about which actual operator it's using, and then it says, okay, I have the operand say here, and then I have the argument list, and the argument list contains this literal string hello world. So that's the whole program. And not just is this what we run off of, so the whole interpreter is basically running eval on each of these levels and sort of digging itself down. And yes, that's not very efficient. But this is also something that's reflected out into the language and can be had at compile time, and we can manipulate it in various ways and basically produce a different program from the program that we're writing here. Does this make 007 homoiconic? Well, I went to the Wikipedia page, and I can say with complete certainty, I don't know. Homoiconic, just like metacircular interpreter, it's one of these Lisp terms where where you go, oh, the data structure of the representation of the language is the same as the data structure in the language. Whoa. And it seemed to imply in the Wikipedia article that you actually need to have the program structure being parsed in exactly the way as the same way as the data structure, and that's not exactly true in 007, but it's very, very close. I would say that the biggest difference, if this were Lisp, then you would see sort of the structure, the nesting structure you have here come through more clearly in the program, but in Perl 6 and in 007, we take a number of freedoms and we can rearrange these things simply because it's easier to write. I guess what I'm saying is that not everything is written in this parentheses and prefix form that you get in Lisp. We have bigger requirements in Perl 6 than that, and also in 007. Whether that disqualifies us to be completely homoiconic or not, I couldn't figure that out. But we make an honest attempt. We're as homoiconic as you can be with this kind of object-oriented AST structure. Moving on. The part where I said this is easy, let's take if statements as an example. Here you see the parsing rule inside of 007. This is actual code. I just took a screen dump of this. Whenever 007 finds an if statement, it parses this keyword if here, and then it expects an X block. What's an X block? Well, it's an expression plus a block. So it's exactly what you would expect after the if keyword. And then you see an optional else here, and that one has two alternatives. You can either do an else and a normal block, not an X block, because you don't have else in an expression, you have the block immediately. Or you can have else, and then we have a nested if in that. So we can do if, else, if, else, if, else, if. Not else if as one word as in Perl 6, or in Perl in general, nor elif as in Python. This was one of the few cases where I didn't do the compromise between Perl and Python, because both of the languages are grinding their own linguistic acts in this case and trying to shorten the word, and they end up in disagreement with each other, which means that both are wrong. So we do the thing that C and C++ and Java do instead, which is much more sane as well, because we're not ending up inventing new keywords. Meanwhile, every time this rule triggers here and parses, we go over to the action method, the corresponding action method for statement if, which means that in our $/variable here we get the complete structure that we parsed out here, and it's available for us. For example, we can get all the information from the X block here and put that in a temporary parameters hash here, and then we can optionally fill it out with the things from the else block as well. And all those parameters here go into a queue statement if object. This is the same queue as we saw on the last slide. This whole hierarchy, by the way, is called queue. Every time you see a queue, it means program structure, basically. The queue is fairly taken out of thin air. It's very, very loosely based on Perl 6's cast, also with a queue. And that queue comes from it simply being an upgrade of past, which was the parrot format. Just think of it as this program representation of the text of the program. And thirdly, this new object that we're creating here, it has a couple of attributes. It has the expression that you see in the code, the mandatory block from the if statement following the expression, and then an optional else. This val none here was one of the primitive types inside of the language. Once you start bootstrapping this, and once you start representing the queue nodes inside of the language itself, you realize that all of these attributes here always have to be representable values in the language. So I'm not allowed to use Perl 6 types here so much if I reflect them out later. It can only be sort of nested queue types. It can be val str, val int, and val none, and val array, I guess. There's a run method here that's bigger than would fit on the screen. That's actually the biggest part of this code. It goes on for 1 or 2 screens. But looking through the code, it was nothing fancy, basically. It's taking these components here and doing things like this, eval on them. So here's where the actual eval logic comes out. This is the interpreter part of the code. All of this comes out as being not very tricky at all. And looking at this code, it's kind of amazing that you do this and suddenly have if statements in the code, in the implementation. This is part of the reason we've been able to iterate fairly quickly on this project. So in a little bit more than a year, we've done over 600 commits, me and 7 other people, seems like, in this project. And now we have not just if statements, but all the components you saw in 99 bottles of beer, and a whole lot of operators and built-in functions and methods and types, and that's pretty cool. This is a really truly recommended way to create a language. And everyone who's been thinking about creating a language, do have a look at 007. It's probably a good example to start from and get inspired by it. I would highly recommend that. It's easier than you think. Here's an example of how easy things are. The tutorial for the language used to do a cop-out here and say, well, you can assign to variables themselves, but if you have an array, the array is actually immutable, so you can't do this. You can't assign to an element of it, because we don't do that, because we're lazy. That changed the other week, because I realized it was easy. Here's why it was easy. I had done a refactor so that the way to assign to a variable was to call a method on qidentifier, which is our variable DOM type. So you just call put value on qidentifier and assign to that variable. When I looked into this, what it would take to assign to something like this, it turned out that, well, this becomes a queue tree, right? It's a lot of postfixes after one another. And the last postfix in the chain here is actually the topmost one, because postfixes, all these postfixes are right associative. So .name here ends up on the top, in outermost in the structure. So if I just added a put value method to queue postfix as well, then it all worked out, and everything else just fell out. So that was extremely little code and extremely pleasant to do, and just by the means that we already had in this implementation. Looking back at what was needed to flip this on, it was like a screen full of code or something like that. So very pleasant and surprisingly easy. In retrospect, I don't know why I waited so long allowing this. And this, by the way, this kind of improvement was also triggered by me trying to write examples in the language. Finally, sort of almost a year later, in this case, I was writing Towers of Hanoi. Oh, I might as well showcase that one as well. So let's exit out of this one. I need to check out examples. Here we go. And we do bin 007. No, that's not the name of the language. Examples Hanoi. It might need to, the pause you're experiencing now, it's actually recompiling, because on the examples branch I have a different state of the file than I did on the branch I left. But here we go. That's Towers of Hanoi. Just to show you the source code, because of course otherwise you will suspect that it's not 007. Here you have, for example, the move routine, which moves one disk from one pin to another. Imagine in a language that insists on arrays being immutable. Imagine doing these two lines here, actually indexing into state, which has all of our pins here with the disks on them, and popping one disk from one pin and pushing it to another. This used to be something like, I kid you not, 30, 40 lines of code in this program, because arrays were immutable. So you needed to iterate through them, traverse through the arrays, and sort of replace exactly the right part with a lot of maps and greps and so on. Pleasant it was not, and beautiful it was not. So that basically convinced me to make everything mutable in the language, including, yes, dog fooding. Dog food for the win. Yes, definitely. That's indeed what happened here. I'm going to switch back to the same branch here and then start off a REPL so it compiles. I wouldn't say that everything is easy. There's one pain point that I keep encountering, and I'll make an attempt here at explaining it to you. So we have this static view and the dynamic view of the program, okay? The blocks that we see, we said that the outermost block has these kinds of invisible braces around the whole program. But then all the other blocks nest nicely in each other, and here we have sort of a block in the main program. And that's what you can see just by looking at the program code. And in this view here, you also have declarations and so on. So all the my declarations, that's the static view of them. They happen once here in each block, and when you did my x up here and you refer to x here, you can do a sort of static lookup and find, oh, it must be that variable that we declared up there. Thank you. That's not at all what happens at runtime, though. At runtime, we have a number of stack frames that we're inside of. And there's some kind of relationship between these frames here and these blocks here, but it's not very straightforward. It's actually a sort of two-level indirect thing, where a frame is associated with a certain block object, which is associated with one of these static blocks. And it can point in a haywire fashion all the way here. And if you get this part wrong, where the frames don't work out or the blocks don't work out, well, then your Fibonacci implementation, your recursive Fibonacci implementation, simply won't work. So this is very, very easy to get right. I know that I don't completely grok this by the fact that every time I make a slightly major change to the project, these are the tests that end up failing, and I end up scratching my head, and I try to sort of pour all this knowledge about blocks and frames into my head before I fix things and forget everything again. So that tends to be a cycle. In every project, there is one of these, these slightly difficult tests that end up failing in different interesting ways all the time. And for me, with this project, it's this static dynamic distinction, which is very, very important. And it's one of these things that as a user, you don't think of it at all, it just works out. This is, for example, the thing that underlies closures and that makes that work. In order to get closures to work right, every time in the runtime, you enter a function, and it has nested functions or nested blocks and so on, you need to do a refresh of those blocks so that they get the right outer. The outer pointer is the one that you follow when you do variable lookout. And it needs to get this outer to be the freshest one, which is the one, the function that you just entered. So that's tricky. However, macros turn out to be easy. Who would have thought? Today, I'm very happy to introduce to you a macro that we just got working before lunch. So this is definitely conference-driven development. For a long time, I've had this idea of the format macro actually being a good showcase for this. Here we show it as a sub, which means that this has no sort of new details that you haven't seen already, which will help you swallow this principle. Please start out by looking at the use cases here. We're basically implementing format as, in this case, just a simple replacement thing. So you could do variable 0, 1, 0 here, and we'll come out with abra, cad, abra, right? And this actually works. It's a little bit long-winded in 007, again, because 007 only has this very primitives, so you can't do cool things. This would probably be just 2 or 3 lines in Perl 6. But you can get there, and here you see for the first time also this nested subroutine. We use basically a helper replace all here, and we send in a transform function which says just look things up in the arguments that we get here. So it's hunting around for these 0, 1, 0 here, and it's looking them up and finding them in the arguments list. We don't have var args in 007, so we have to send this one in as an array. It's on the roadmap to actually get var args, but that will be a language extension so that we can investigate slangs a bit. So it won't be core. When you implement this, my first naive implementation of this was a while loop that basically went hunting for opening braces and closing braces and replacing them one by one. If you do it that way, you open yourself up for a vulnerability where this, for example, would fail because it would replace the $0 here, the braces 0 with a braces 1, and then it would find that one again in the string because it just showed up in the string it's about to replace. And then it would try to look for braces 1 and it would fail. That's not at all what we want. We want it to sort of traverse things right from the beginning to the end. In Perl 6 you have comb, you get this sort of for free if you do that with comb or some sort of global replace. But here we have to do it the hard way, so we make a recursive subroutine to do that. Now, here's the main point. What if this were a macro? what if format were a macro? Would we gain anything from that? Yes, in some cases, we could do static verification that we're actually not using placeholder things here with too high values, like if it would index out of the array. We can't always do that because there's nothing particular in the format macro that says that we have to have a constant string here and a constant array here. But given that we have both of those, we have enough program structure here to actually analyze and catch very, very early the kinds of errors that would show up. And I want to live demo that as well. Actually, let me show you the code that does the compile time checking first as well. So we changed two things here. We changed the sub here into a macro instead. It's just changing the keyword. Instead of doing this replace all here, we return code that does the replace all thing at runtime. But then we also have a compile time check before that that says if what we're seeing is a literal string here and followed by a literal an array term here, then we can find the highest used index here with the helper sub. We can find the number of arguments in that array, compare them, and actually die if they're inconsistent, if we're using an argument that's not present in the array. This is strictly better than what people have in C, I guess, or they probably have a macro in C++, don't they? I'll leave that unsaid, or a template or something that does this at compile time. But it's better than what Java has, it's better than what 12.5 has, and so on. And this is a clear advantage that macros give you. And we actually got this working this morning before lunch, so I want to show you. Really proud of this. Examples, format. Here's the code. You see we have now replaced subformat with macro format. And here's the helper sub find highest index. We're not going to look at that. Here's the code that actually checks this. Checks for the literal string and the array, and then does the die and so on. Thank you. This morning, we did not have die in the language. It turned out we needed that. And it's a testament to the ease with which we can get new features that it actually took less than 20 minutes for us to get die in the language. The workaround we had was so funny, I have to mention it as well. We want here the error to be an out-of-bounds exception. So what we did before we had die was actually to index an array that was too short with exactly the right dimensions, having it fail, so you can get a sort of poor man's die by failing in exactly the right way. But let's not do that. Okay, this last line will fail at compile time, so I'm going to comment that one out. And now you see it's exactly the same one as in the example. Let's run those, bin 007, and this file here. So at runtime, we still get the right result here. And just to be really, really clear, we still have the same code here running. It's now returned inside of a quasi, and this is specific to macros, because when subs return normal runtime values, which could be anything, macros are expected to return small program fragments. And the easiest way to build a program fragment is just to say, yeah, we have a quasi here, it's some code, turn that into a Q-tree and return that. And inside of that, we can also escape out of that environment and actually pull in macro arguments and so on. Now, if we re-enable this one, we will see the newly implemented die feature, and that's a wonderful stack trace. But at the top of there, you see the actual die message that we get here. Highest index was 1, but got only 1 argument. And that's indicative of the array being too short in this case. Cool, so it works. So that's a real honest-to-goodness macro without any shortcuts whatsoever. I'm going to skip the closures live demo in the interest of time. And in the remaining 2 minutes, just mention hygiene, which turns out to be the central problem of this. Namely, you have an X inside of your macro here, and you have an X outside in your main line. And when you do foo.x here, I guess your intuition all says that it's this X here that we're supposed to be using. But the problem is X comes in as the expression here, it gets replaced as being X, and the program environment is very, very likely to see this inner X here, which we shouldn't at all. So hygiene is all about keeping track of which variable is where and which one we should use, okay? And the general guideline for hygiene is that there should be no surprises. If we think it's this X outside of here, then it should be that one. The biggest contribution that 007 has done for me, thinking-wise, is how to solve this. I first went in thinking, okay, I can do this with closures. Closures are great, which is why I wanted to demo them. So we put invisible closures everywhere when we do macro expansion and macro arguments expansion and so on. That turns out to work, actually get you pretty far, but it's a dead end. And why is that? Because macros are further than just expressions and statements. You could, for example, expand into, thank you, a trait. You can put traits on subroutines, and those can have expansions as well. And you can't put a closure there because it's not an expression. It's sort of outside the entire expression statement system. So what we instead do is we associate every identifier with where it comes from. So here this frame abstraction comes up again. You're not just X anymore. You're X from this particular frame. 007 has 418 tests at this point. We're using tests really, really much. Recent test that we got, man or boy test, it passes because it's a real compiler. Test I didn't expect us to get, checking for white space, line endings, no spaces at the end of lines, the correct number of indentations and so on. When we got more contributors to the project, we also got these tests, which gave much better pull requests. Kind of a happy surprise. I'll skip this one. Kind of future directions here as well. I think I'm out of time, so I'll save those one. If there are any questions, we may have time for that one. Here's the address for 007, and remember, pull requests are love. Thank you.
We do actually have time for about 1 or 2 questions. No, it's fine. But it seems we have none. So let's thank Carl again for this inspiring talk.
Thank you.